Friday 15. So I could not let this season go by without having the man himself, Bob Dagostino, here on the program with us. And that's because this year, 2023, marks the 50th anniversary since the founding of DES in 1973. So our agenda today is very simple. We're going to do 50 minutes for 50 years. We're going to race through 5 decades of telecommunications and see how we got from this mustard rotary phone to this hyper-connected society that we have today, and the role of DES in making all that happen. Bob Dagostino, welcome to the program.
Thank you for having me here today, Dina.
You're welcome. Okay, so Bob, set the scene for us. Telecommunications circa 1973.
Oh my.
What did it look like?
Well, it looked like this. The regional bell operating companies had a phone in your house or in the place of business, and they maintained, managed, installed, did all that for you as a service, multi-service by the phone company.
Right, and telecommunications was pretty much, in terms of connectivity and communications, it's phones.
That's it.
It's phones.
Pretty much phones,
right?
That's it, yep.
And then something happens. Something erupts. The information age comes to life.
Right.
Why? Around like the late 70s, like something happens.
Well, I'll go a little bit beyond that, and I would say the deregulation of the phone company came to be. And what that allowed was for businesses and consumers to own their own phone equipment and plug it into the public switch telephone network, which was maintained by the bell operating companies. Mm-hmm.
Right. So then you have the infrastructure changed. But what about the technology itself? What are the certain innovations that happened?
Oh, so much. Well, I'll tell you what, I think anytime you open up the innovation of private business, they come up with some really cool solutions. And, you look at how the as-is situation is for an office. For example, back then, offices had a switchboard operator, and that switchboard operator would answer the calls coming into that place of business. And they knew there was an in and out box there so that the operator knew who was in the office and who wasn't. And if they weren't in the office, they had these little pad of pink slips, and it said while you were out. And the operator would take a note that, Dina called while you were out. Please return her call as soon as you can. And that's really where the business, the gatekeeper, if you will, of communications was.
Right, but then things developed so that the gatekeeper doesn't end with usually the lady with a pink slip, but there's an actual automated system that starts happening.
Oh yeah. I would say one of the coolest things that we started to interface with telephone systems, that once a customer bought into owning their own telephone equipment, one of the coolest things that we installed was that which was called voicemail.
Voicemail, okay.
Voicemail,
so yes. This is DES iconic technology project. So first voicemail. So give us an example of.
Well, voicemail was very interface to a phone system, so that if the operator transferred the call back to an extension of the business there, and it would go through a ring no answer, then the voicemail would answer with a greeting of that individual saying, "Hi, it's Bob. I'm not here right now. Please take the time to leave me a detailed message and I'll get back to you soon." And then the caller would leave a message that was recorded on a hard drive disk. That was a big change there, so that people would then be able to retrieve their messages wherever they're at by dialing into the system and hearing what messages they missed while they were out. Same time, when that voicemail message did come in, it could even alert you. And back then, people were carrying pagers with them.
Right.
So their pager would go off and they say, "Oh, I got a voicemail, call the office and see who I missed." So that was one of the early things Then
Right.
that started to evolve into what we called IVRs, integrated voice response systems. And that would be an interactive computer, if you will,
Right.
asking questions. And by pressing buttons on your phone, the DTMF digital, the tones of the phone would route that call accordingly.
Right. So I'm thinking, so I know one of your early projects was for these major national call centers,
Yes.
right? So,
Yeah, I'll tell you what, one of the, I'd say the most interesting engagements that we got was with a group called Reese Brothers. And Reese Brothers started out as a public awareness call center here in Pittsburgh with just, I think it was less than 50 people. There, the agents would simply do what we called smiling and dialing. They just pounded the telephones, and what happened there was a few things. One would be either the call would go into a ring no answer,
Yeah.
which nobody's home, or it would go into a tritone intercept, meaning that you would hear just boop, boop, boop. That number is no longer in service status, or you get someone that would answer the phone and say hello. And I would admit there is a fourth, and that would be at some point in time people began to use answering machines.
right.
So that was what the calling agent would do. Would be, if it was ring no answer, they would stage that card maybe every 3 hours from now, try to ring that same number, because evidently they're just not home. And so that's where it started, just by just dialing a phone. But the business model on that was that the talk time that the agent got to speak with a connected party was only maybe somewhere around 15 minutes an hour.
Right.
Okay.
Right. So you have this agent call center, and I know that Reese Brothers, one of their big iconic projects that everybody here knows about is MAD, Mothers Against Drunk Driving.
Yeah.
So you're calling about trying to fundraise, trying to raise awareness for that. And they do this manual process. You call, maybe there's no answer, maybe somebody answered, maybe there's an answering service, and you're just writing it down on pieces of paper and categorizing your time in that way.
Right.
And it's 15 minutes of just actual active talk time per 60 minutes.
Exactly.
Along comes DES, and you create this whole actual call center.
Well, I tell you what. First off, the Ralph Reese was very innovative. He always challenged status quo. He always wanted to try to put more technology into it, from just paper to spreadsheets and on and on and on. But what we did was there was a group out of Carnegie Mellon University who came up with a automated dialing dollar. And what that did was all of the information of who they were calling, what their phone number was all just put into a database. And that database would get called by the computer. The computer would then listen to whether or not those 4 different statuses of call disposition was ring no answer, tritone disconnect, voicemail, or someone said the word hello. And with that, it gave us the ability to let the computer sort out all those ones that they didn't reach a live person, and only the callers that answered the phone by saying the word hello, and typically that's what people say. We listened to that cadence, the word, and said, okay, let's transfer their call immediately to an available agent so that they can make the presentation of the public announcement of many nonprofit organizations, such as Mothers Against Drunk Driving, Just Say No to Drugs, Prevention of Child Abuse, and a lot of other good organizations.
Okay, other iconic projects. You mentioned CMU. I know we did stuff there.
Carnegie Mellon University. Pittsburgh very well known for having a very strong technology and higher educational folks. And one thing that we got to do with Carnegie Mellon in conjunction with IBM was to build the Andrew project there, which was known as the campus of the future.
Right, the legendary Andrew project, which was almost like the first one-to-one technology premise. They wanted every student and every faculty member to have their own computer, and this is in the early 80s.
It is, right?
Yeah, and you were involved in actually.
We were the contractor that actually did the physical installation of the IBM cabling that made that network connected.
So we could argue that robotics that comes out of CMU is based on the infrastructure.
Well, it very well could, but
Yeah.
I mean, just the idea that how networks have evolved over the last few decades of being just a print share type of network where multiple computers just wanted to share a printing device, to how it's evolved to today.
Right. So which comes to things have evolved a lot, and we're at this new frontier of telecommunications. How do you see that? Like, what's the difference between where we were 20 years ago when this information age erupted and where we are today? Like, what's the main differences?
I spent some time up at Henry Ford Museum to see what the industrial age revolution was all about. And here we are today, and we're in this information age revolution. Some folks are referring it to the fourth industrial revolution or industry 4.0. And what it's all about is things. Things. And it's coined Internet of Things, or industrial Internet of Things. And that's any kind of device that can capture any kind of information, can connect and talk to other things that are out there.
Right.
And we're excited to be able to leverage all those endpoint devices and bring them together so that we can create smart buildings, smart schools, smart cities. That's an initiative that we're driving right now, leveraging the fourth industrial revolution.
Right. Yep. And which brings us to our more futuristic question: space lasers. What's to come? Are we going to have space lasers?
Well, here you go. We're always challenged with transmitting more and more data from one point to another. And one of the things that's been done in the past is utilizing fiber optics. Fiber optics used anything from just LEDs flashing to lasers. But now NASA is testing out the use of free space optics, and the free space optics will give high bandwidth capacity to transmit data all the way from outer space to Earth here. And that, to me, is exciting, free space optics and what that can do.
And for the common person, free space optics, so you're talking about, that's the light spectrum?
That is the light spectrum, yeah. That is the light spectrum. There's both visible light and infrared light that can be modulated up to transmit data.
Right. So right now, we have been used to here in the information age to have wireless communication. That means through radio waves.
Right. That's RF.
Yeah,
that's
RF. Okay.
RF part of
the and then suddenly now we're going to transmit data through the light spectrum, and suddenly that opens up a whole new way. It's quicker,
and the other interesting factor about it's not regulated by the government. Yeah, whereas the RF spectrum is it's a very regulated type of offering.
Okay, so I want to end off with some resources and recommendations. So 5 decades in the telecommunications industry. Tell us what made you be who you are.
I'll tell you what, curiosity, asking why, just hanging out with groups that are creating standards in the industry. NASA has been a very influential to me for my for 50 years, in all sincerity. You
Yeah.
know, when the president said we're going to put a man on the moon, I got involved back then and have been following NASA. And you know what, as a factoid here,
Okay.
NASA is one of our customers here today.
NASA. So talk about those iconic projects. Got NASA. We have Heinz Field, or Acrisure Stadium, I should say.
Stadium, yes.
You know, the whole like it's a whole environment, creating a whole environment based on data communications, and it's certainly a huge step from 1973
It is.
to be where you are today.
Voice, data, video, communications.
Everything.
And there's things to come yet that we're excited about presenting.
Good. And if you want to know more about anything we do, first port of call is our website, DES Technology at Work. See it all there. So thank you so much, Bob, for joining us today and for sharing with us 15 minutes, 50 years.
All right. Thank you, Dina. Appreciate it.